Okay, yeah, but they probably didn't do any of that. Like, reached out to like 1,200 people. Like, probably just put a flyer all over the order and be like, oh, community.
Okay, we're just gonna get started with question 1, and we're just gonna go 1 through. I think we're doing 1 through 11. We're skipping.
Skipping 8, 12, 13, and 14.
Yeah, well, I don't know what just happened here. Hang on. So again, the numbers we're skipping, we are skipping 8, 12 through 14. Alright, so error approximation is not going to be on your test, so we don't have to worry about that. You will pay for it though on your next test. So
like a 30-point quiz, or is it like
17C? Yeah, that's what I was going to say.
no, 17C is fine. It's, technically speaking, 17C is not an error approximation question.
Probably because you're actually finding what the error
Because you find out the exact value of the error. So we're not approximating the error. So we're just going to go down the list then. Number 1.
That was that thing with the calculator.
is this gonna be like a 30-point quiz, or is it like 100 point? The test.
This is going to be a test.
So 100 point.
100-point test.
Okay, so there's hope.
So we got 2 plus 2 over 7 plus 2 over 49 plus 2 over 343, just in case you didn't get it yet. And the realization that you need to make is that this is a geometric series. Geometric series, first term is 2. The ratio is 1/7. And by the way, 1/7 is less than 1. Sorry, the absolute value of 1/7 is less than 1. So the series will converge to first term over 1 minus the ratio. That's equal to 2 over 1 minus 1/7. See, 1 minus 1/7 is 6/7. 2 over 6/7 is 2 times 7 over 6, which is 7 over 3. Unless I did something wrong. Just 7 over 3. So again, series converges to 7/3. Although I suppose we could have just stopped right here. We're supposed to just figure out if the series converges or diverges. And as soon as you see that the ratio is the absolute value of the ratio is less than 1, you know that you have a converging series.
Well,
Okay.
the answer says like the actual like sum, so
Oh, okay. Yeah.
so then we're good.
Yeah. We just went above and beyond. That's all. Which is good because we're all AP students in here.
Is there like one additional term for when it converges to? Like if it, like, will there ever be, like, if it does.
Okay, everyone, you know, it's not a problem. You can sit wherever you like, of course, but I do need to hear when people are talking. So if you add, you know, errant noise to the room, it's really difficult for me to focus on whoever the speaker is. So.
Oh, I was just saying, is there like a special term for like the number it converges to? Or is it just like the number it converges to?
No, there's no special term for it. Yeah. Yeah.
So just making sure when the ratio is either 1 or greater than 1, then it diverges? Or
The absolute value of
when the absolute value of the ratio is 1 or
less than 1.
less than 1? Oh.
No, but when
No,
it's
no,
greater.
diverges, not converges.
Anything else?
Okay, cool.
So if absolute value of the ratio is less than 1, the geometric series, and it has to be geometric, has to be geometric. Okay, everything else diverges. Any other values of the ratio will produce diverging series. Gosh, I keep thinking that I have enough room and I keep having to move this blue line. It's kind of annoying. Diverging series. There we go. Whew. Yeah.
Also, this arithmetic, it would be divergent.
Any arithmetic series will diverge.
No matter what.
Question, Max.
No matter what. Okay. Part B. I'm sorry, question 2. Question 2. We have series -1 to the n, 3x to the 2n. We're supposed to figure out if this series converges or diverges. Oh, find the values for which this converges or diverges. So again, like I was saying in period 6, they're going to expect you to be lazy, impatient, and have short memory. So first lazy thing that you would do is you would not write out this series. Okay. Let's not be lazy. Let's write out the series. When n equals 0, I have 1. When n equals 1, I have -1 to the n, so negative, and 9x squared or 3 squared x squared.
Yeah.
Actually, let's keep it as 3x squared. When n equals 2, I have -1 squared, so plus, and then 3x to the 4th power. And when n equals 3, minus 3x is 6 plus dot, dot, dot. Now in this case, it's probably not necessary to write out that general term because we're only trying to figure out the values for which this converges. So, question number 1. Is this or is this not a geometric series? Okay. So this is a geometric series, and I highly, highly recommend, which means you need to always write geometric series. I can't stress to you enough how important it is for you to write that out. It tells the reader that you are thinking and you realize what kind of a series you're dealing with. Okay, first term.
1.
Okay, again, write it out. Don't be lazy. First term is a 1 and then the ratio.
Negative 9x squared.
What are you saying? You said sin x squared.
Negative 3x whole thing squared. Okay, so a geometric series will converge for absolute value of negative 3x quantity squared less than 1. How do I know that? Because it's a geometric series. If you did not write the word geometric series here, it looks like you're guessing. That's why you write the word geometric series. Okay, so we're supposed to simplify that. Now I think it's okay. Let's see. Absolute value of a negative number is positive, of course. Hold on. Hello. Okay, I'm going to send someone out to the main office then. Okay. Yeah, it should be Taft High School exactly. If you bring it just to the front door of the high school on the what's it called again? On the Ventura side, then we can send someone out there to pick it up. Okay, so we'll send someone out right out there. Okay. Okay, thanks. Must be new. New driver. Yeah, new kid. Okay. Just wait for him. He's probably going to be driving. Flag him down. All right. Simplify that. We get 9x squared must be less than 1. Okay. And you know you don't need the absolute value because that x squared is already positive. Okay. Divide by 9. X squared should be less than 1/9. Next, apply a square root. Okay. This is a place where your people screw it up. Square root of x squared must be less than the square root of 1/9. Okay. Square root of x squared is, see this, y'all just got it wrong. Y'all got it wrong.
Negative 1.
Absolute value of x.
Absolute value.
Absolute value of x. What?
Oh, because it's no
Because
longer
it's not
squared.
squared. I got you.
That makes sense.
Oh, but it doesn't have to be plus or minus.
Nope.
Now it's plus or minus, but
I
it's
just, I like.
Okay. So if I solve that out, I have x must be between 1/3 and negative 1/3. Of course, if you want to be a fancy pants, you can write it interval notation. Do this like a mathematician.
That's not.
No, thank you. Okay, and that kind of takes care of it, right?
Yeah.
Great. Let's go to question 3. No. Question 3. It's actually the same question. We have a series that looks like this. Is that 3x plus 1
Yes.
to the n? Okay, so they're hoping that you don't recognize that this is a geometric series, or they're hoping that you don't actually write out the terms, or do not give yourself enough clues to realize that this is a geometric series. Just like before, we want to write out the word geometric series. Probably spell that correctly. We're going to define ourselves the first term. Yay. First term is 1 ratio is 3x plus 1. Okay, series will converge. Series will converge if the absolute value of 3x plus 1 is less than 1. Right, so now we're going to have to do some work here, right?
Yeah.
So I'm not sure about how you all do this. What I would do first is actually multiply everything by 1/3.
To get rid of the. I mean, why?
Okay, that gives me x plus 1/3 must be less than 1/3. Okay, now that I have this looking like this is actually similar to absolute value of x minus the center is less than the radius. The center of my is negative 1/3. The radius is 1/3. Yeah.
Is the center what's like the number in the absolute value, and then the radius is what it's less than?
Yep. It's x minus the center. X minus the center.
How did you know to do that?
Because I do this every year.
How would we know?
Because we're doing it now.
So it's not zero, not zero. That's what you're saying.
Yeah. Center of this polynomial is not 0.
So if it wasn't zero, how would it be?
Let's keep going with this, everyone. So x will converge for, series converges for x between center minus the radius. Oops. Center minus radius to center plus radius. Center minus radius, negative 1/3 minus 1/3
Negative 2/3.
is negative 2/3. Center plus radius, or, again, if you want to be
So wait, why'd you put 1/3 as a 0?
oh, that's a 0, yeah. And just to kind of clarify about this, the reason we do it this way is because it is fast. Again, the reason we do it this way is because it is fast. The other way that you would have been able to do this, alternatively, okay, what was that? 3x plus 1?
Yeah.
Had to be less than 1. So you get 3x plus 1 between 1 and negative 1. Negative 2. Multiply by 1/3. The question for you, what is, if you do it this way, what is the center of the series?
Negative 1/3.
How do you know that?
Well, you can break
Yeah, I mean, is he gonna ask?
Yeah,
Okay, then yeah.
and the question is, will you be asked for the center of the series? The answer is yes. Okay. Didn't I just say yes?
Couldn't we just?
Again, just in case you weren't listening because you're talking, yes, you will be asked for the center and the radius. Okay. So, you know, part of me wants to tell you that no, it doesn't matter which way you use. Okay. But the other part of me, the one that's trying to make sure that you understand what you're doing, says, I don't want to take any chances. I want to make sure everybody gets the center and everybody gets the radius. This way ensures that you have a center and a radius. And it's not really more difficult. Okay, you don't like fractions, you don't want to multiply by 1/3, divide by 3, whatever. But if you multiply by 1/3, then you can see the distribution property in work. It's the only reason why I prefer you to do it that way. So, yeah.
So you have to get x by itself in order to get the center and radius?
No. You have to turn it into x minus center. That's not solving for x.
No,
Like, he means reduce x to just.
The coefficient of x needs to be 1.
okay.
Ted?
I was asking basically.
Okay, yeah. The coefficient of x has to be 1. Once the coefficient of x is 1, then you have a form where you can just read the center and the radius.
What if the ratio is a polynomial? Then,
Ratio is a polynomial. Oh, more than a first degree polynomial.
like, for number 2. Like,
Mm-hmm. Yeah, you would have to solve it.
okay.
Yeah. You probably won't have to do something like complete the square or anything like that. It's usually a pretty easy polynomial to solve. Okay? Well, if you take a look at this over here, from negative 2/3 to 0, that has a width, which we're actually should be calling a diameter, of 2/3. So if the diameter is 2/3, between the center and the edge, yeah. Okay, let's do this. We're gonna do number 4, and then it's gonna be pizza. No, yeah, number 4, and then we're gonna do pizza time. Okay. Now that the cheese has had time to solidify, but not too much. You could.
How much time we have?
Okay, again, write it out.
I'm lazy though.
Maybe that's who you're targeting. Targeting you.
I know you're lazy.
Basic.
Okay, so you see it's geometric. You see the series, you know it's a geometric series. You know the center, no. Well, you could do the center, but the first term is 1. You know the ratio, not ration, ratio is x plus 2. And what are we supposed to figure out? We're supposed to find a function, right?
Yeah.
Okay, so the function here is going to be first term over 1 minus ratio, which is equal to 1 over 1 minus quantity x plus 2. So f is 1 over negative x minus 2. Or you could say negative x 2 minus 2. Does that work?
Yeah. Wait.
Plus 2.
Just leave it
Yeah,
the
it's
way
1.
it is.
It's 1. There's a 1 down there.
Minus 1.
So it's
1
1
minus 2.
So negative 1.
Negative 1. 1 plus x.
No, the
Yeah,
one on the
it's
bottom
one
right
over
is
one.
1 over 1.
You like that?
Because 1
Oh,
minus
it's
2.
Just the top one.
No, but it's still 1 instead of 2.
Same thing, right? Converges for the absolute value of the ratio less than 1, which would be absolute value of x plus 2 is less than 1. Series converges for negative 2 minus 1, negative 2 plus 1, done. All right, pause for pizza.
Or X minus the best reason.
Huh?
That's still like, that would still apply to like x minus n.
That's exactly what we're doing.
Oh my god.
No, but that was
think it's gonna be. I went to the stat test today because I should have done one
So you guys won. Oh, this is cool. So they gave us. Is Evan on your video? Everyone cheat. Everyone stop. I didn't know. It's like Marley.
How many can we grab
And then you back to
Well, you know what? I have to. Yeah.
That's so cool. Wait, Bella, what is on that pizza?
Mushroom? No, not mushroom. No, wait, yes, mushroom, onion, olives, and sausage.
Is there cheese somewhere?
Yeah.
Is there cheese on it?
Why didn't I buy that?
We're doing 500.
There's one there. I just didn't want it.
I feel like she doesn't care about it.
Oh, okay. I was like so worried. Is it not good?
Did we actually want this?
This is very scary.
How much of brush is
Yeah,
that?
but I put money in there. Is there a napkin on my bag? Are we all
You know the Ferrero
Yeah.
shake?
Is someone not dead?
Oh, we did?
That one left?
The country of Nutella.
Could someone carry it? It did not move.
You start ordering them.
I have some napkins if anyone would like one.
So,
Yes.
when he talked,
Where are we?
Wait, Laura's really not. No, I keep thinking that today's Tuesday.
Can I get change for a bag?
Only what's in there.
Does anyone have change?
You should do chime.
Yeah, it's on. It's working.
You should get your mom.
Oh, okay.
Anyone else?
Teaching at her school so much. It's like, her student, like every day she has like a new story about how one student was like, how to save myself for you. So yeah, her just like, you can't just make a normal teacher. They used to not like it, like barbecue sauce, but I think a barbecue sauce would make it.
Apparently they do.
Apparently we got rid of our special ed coordinator, so now we have
That's
one,
great.
we have one of our admins cover for their
Really?
full-time job.
For the end
Yeah,
of
with
review?
her own admin. It's so stupid. So yeah, we should start ordering them. There's not much.
I think it's still.
No, we always order two. Yeah, we did every single
There are 2 olives and a martini. One falls out. One says to the other, "Are you okay?" The other says, "Olive."
Are you like
Yeah.
I don't know if it's all.
Was this in regular Airbender too?
Oh, I'm watching them right now. This is a book. I don't know if you like it, but I don't think Did you watch the original series?
I did.
I'm rewatching them all right now, and they're beautiful. And
I'm not going to do that. I have no idea. I mean, I don't have an idea. I'm not going to. I refuse to be defined by what I assume.
Or would you
When was the last time you
Synthesis.
Are any of these not going to be geometric?
If it's not geometric, it's going to be E, sine, cosine.
And then when you solve it,
That's not nice.
did you use all paper towel?
Nope, they're inside the dispenser.
I was looking for this one. I'm gonna make a steady bit.
They're best friends. Why do you think they're not doing? No, not in my class.
Okay, so let's get started then. I think it's about that time. I'm going to try and annotate the YouTube. I haven't tried before, but I'm going to try and annotate the YouTube video so it skips pizza time.
Yeah. Oh yeah, 'cause usually it is pretty good. When I watched it before, I just put like
So,
wait, why did you just pause it during pizza time?
meh.
I feel like it'd be so much easier than annotating.
Partly because I want to annotate it. Okay, again, they're hoping that you're going to be lazy, impatient, and have short memory. Yeah. Daiso, $1.50.
Do you want to dice up? My mom obsessed with that.
As she should be.
So good. That's where all the highlights.
Okay, substitute a 0 for n, you get 1. Substitute a 1 for n, you get negative.
X minus 3 over
Yes,
10
Brian.
first power
Do it, Brian.
Substitute a 2 for n, you get
plus X minus 3 over 10 squared.
substitute a 3 for n, you get
Negative X minus 3 over 10 cubed.
great. Is this a geometric series?
Yes.
Thank you. This is a geometric series. First term, the ratio, negative negative x minus 3 over 10. Good. All right, so what do we have to figure out here for 5?
The function.
The function represented. Good. Function is going to be equal to the geometric sum. So it's first term over 1 minus the ratio. 1 minus negative x minus 3 over 10. Whoa, boy, that's a headache. Let's see. This is equal to 1 over 1 plus x minus 3 over 10.
X minus
10 over
Which
10
is 1 over 10 plus x minus 3 over 10. So f is going to be equal to 10 over, that's 7 plus x.
x plus 7 plus x. Same thing.
This will converge for absolute, yeah, x minus 3 over 10. Yeah, there's a negative sign there. Less than 1. You want to simplify that. That's the absolute value of x minus 3 over 10 is less than 1. Multiply by 10. Absolute value of x minus 3 is less than 10. Center is 3. Radius is 10. So converges for x between, let's see, 3 minus 10.
Not positive.
3 minus 10.
Oh, negative.
3 plus 10. Hmm?
Oh, it's center minus.
Center minus radius. Oops. Center minus radius to center plus radius. By the way, do you think I'm going to be picky if you put less than or equal to?
Yes.
You're right, I'm going to be picky. Okay. Has to be strictly less than. No equals. Okay, that takes care of question 5. Let's look at 6. We only have a couple more to go here, folks. We are going to be done way before 5. Maybe not, I don't know. Okay, x sine 2x. Okay. What we're going to do here is we're going to take the known series that is most closely related to this, and we're going to slowly and surely just craft our way to this function. Yeah, so this is most closely related to sine x. Sine x. And okay, sine is an odd function, so we need the odd powers.
X minus
oops, plus
Plus 1 over 5 factorial x to the 5th.
That's 1 over 7 factorial x to the 7th.
Next stop.
Don't just sign and close the file. If you actually
No. Otherwise, 1 over 7 factorial x to the 7th. The green is pretty blending in.
Yeah, the green looks very much like the black.
that's green.
That looks
If you look at,
It's easier to tell because it is more.
Okay,
Oh, the side one.
we're gonna replace all of those x's with a 2x. So we have sine of 2x. Next, you want to multiply.
Distribute the x.
You know what? Let's do this. Let's simplify this a little bit. So we're just kind of separating it out. Try to keep that x cubed, or all of the factors of x, try and keep it separated from the rest of the junk. Lastly, you're going to multiply each term by x. I don't know, we'll take a...
distribute the x to all and then like not write x next to them.
Yeah. And then distribute, simplify. Sine of 2x equals sine x squared, 2x squared, 2 cubed over 3 factorial x to the 4th, 2 to the 5th over 5 factorial x to the 6th, minus 2, 7 factorial x to the 8th plus dot, dot, dot. Okay, so now the question is, do we need to worry about the general term?
No.
No, we don't. We're done.
It says it doesn't tell us. It says just find the first one.
Can we just simplify?
No, that's simplified.
Okay, because on the answer it's like, is it not matter?
No, that's fine. Yeah. That's about as simplified as I want it to be.
Okay.
Our questions like are there going to be 2 FRCs
2.
And then like add both are they weight equally? Are they weight equally?
Okay, I think we're on question 7. 7. Okay, so important note about 7. Is the center 0? No. So that means start all over again. The center of the polynomial is, what's that, pi over 3?
Yes.
Which is not 0. We need to use Taylor's theorem to build the polynomial. Okay? Center is not 0. You need to start all over again with a polynomial from scratch. Okay, which means we're going to have to get our derivatives, right?
Yes.
Okay, so what is f of x?
Cosine of x. At pi.
Cosine of x. F prime of pi over 3? No, f is cosine of pi over 3.
Rad 1 over 2.
Yeah.
So it's 1 over 2. 1/2.
Wait, rad 1 over 2.
1/2. Good. Hey, how many terms do we need?
3.
Oh, Lord. F prime of x.
Sine x.
F prime of pi over 3 is equal to the negative sine of pi over 3. What is the sine of pi over 3?
Rad 3 over 2.
Rad 3 over 2. So.
Negative rad 3 over 2.
Okay, that's going to give us 2 terms.
Last one.
Because the center is not at 0.
Second derivative.
Negative cosine.
Did we skip number 6?
Negative 1/2.
Yes.
Okay, that's going to be 3 terms. Do we need more?
No. That is all.
Yes, we do.
We do.
We need one
Oh,
more.
non-zero. Oh, yeah.
No.
No, we don't.
Third order.
Needs to be third order.
Third
Oh,
order.
so you need to find the
Oh,
third.
I know, it's
Okay.
because it's a known series.
One more
Smith
term.
line.
One more term. F prime of pi over 3 is equal to the sine of pi over 3, which is rad 3 over 2. Good luck. So what are we saying here? The question asks for third order polynomial. Okay, so this means we need to go to the third derivative and the highest power of the polynomial should be 3 or less. Okay? That's why we needed the third derivative. And how come I'm not writing this correctly? That's better. Let's write out our polynomial. F of x can be approximated by. Now that we know that the center is pi thirds, it's going to be equal to f of pi thirds plus f prime of pi thirds times x minus pi thirds plus 1 over 2 factorial second derivative at pi thirds x minus pi thirds squared plus 1 over 3 factorial triple prime pi thirds x minus pi thirds cubed. Again, we want the polynomial, so it should be approximate. We want the polynomial, so we don't put plus dot dot dot. We just stop right there. F of x approximated by, what was f? Was that 1/2?
Yeah.
1/2 minus root 3 over 2 x minus pi thirds minus, yeah, 1/2 times 1/2. Maybe I should just do this. 1 over 2 factorial times 1/2 x minus pi over 3 squared plus 1 over 3 factorial root 3 over 2 x minus pi thirds cubed. F of x simplifies to 1/2 3 over 2, that 1/4. See, 6 times 2 is 12. Yeah, honestly, this is kind of optional. You know how happy I would be so happy if you just left it like this.
Yeah, would you be happier if you simplified it?
Well, it's gonna be multiple. This section is multiple choice, so it's basically whatever is on it.
You're right, though. If this is multiple choice, it is going to simplify. Yeah.
So third order means the third derivative.
Third derivative.
Okay, why didn't you write or less?
Because it's possible that the third derivative is going to be 0.
What if it is?
If the third derivative is 0, then the highest power is going to be 2.
Should we include 0 in the equation though, just to say that like we
I would probably do that just to be certain.
Okay, but it'd be multiple choice. True. It's whatever multiple choice.
Yeah, 10.
It's like on the AP test, will the answer choice have the factorial in there, or will they multiply it out?
I've seen both.
So just be prepared.
It kind of depends on what they're actually testing you on.
How many multiple choice questions are there in the AP test?
28. No. 45.
Oh, that's very big. That's a big difference. Well, it's probably 28.
It's 28 without a calculator, 17 with a calculator.
There's different sections. Responses too.
Oh, goodness.
It's a long test. Long test, hour and a half. It's about, I think they give you right around 4 hours. 50 minutes for 28 questions, 55 minutes for 17 questions, hour and a half for 6 free response questions. It's a long test.
So,
We should get like food. Yeah.
yeah. Yeah, we do get a snack.
Oh, they should like give.
Get your apple slices.
Yeah, can we? No.
I'm never there. I can't tell you.
That would be like
I'm not allowed to be there.
Wait, brain pizza? And
I'm
it's
not allowed.
Fold and a Ziploc bag.
Number 9. Taylor polynomial order 2 to approximate cosine of 0.2. And, you know, I don't know about you, but if it was me and I don't have a calculator and I'm asked to approximate this, I actually don't want that as 0.2. I want that as 1/5. It's gonna be a lot easier to multiply 1/5 than it is to multiply 0.2. So we want an order 2 polynomial for cosine of x. Order 2. Oh. Order 2 means. Ah. Order 2 equals highest power is 2 or less. Okay? All right, cosine of x is going to be equal to, let's see, cosine is an even function, so I need even powers. The first even power is 0. X to the 0 power is 1. Next one is the second power, second degree, x 2 over 2. Oh, we're done.
Oh.
That it?
That's the second order polynomial, right?
Oh, I thought we had to put in the second derivative.
Wait, I thought second order was.
Oh, you didn't like write it.
So, I
So
thought,
for the
I mean, we're not done, but that's.
yeah, I know, but so isn't there one more value?
like for the previous problem, you don't need the third derivative.
Yeah. Remember, this says order 2.
Like you count the amount of roots because it's the first and one.
No. You have to go by the power. Second power.
Derivative is one square, but like the previous also with the third power, the answer doesn't. So one is
It should have.
and then x squared is 9. It doesn't.
That,
So when they're asking for an approximation, they're not asking you to center it at 1/5. They're asking you to just center it at 0 and find it at 1/5. Okay.
all right. Cosine of 0.2 is going to be equal to 1 minus half of 1/5 squared. 1/5 squared is 1/25th.
So 1 minus 1 over
1/25th times 1/2 is 1/50th.
1 minus.
And we don't have to put that back into the decimal. Well, I guess we do.
You don't have to. But, you know, that one's pretty easy.
Yeah.
0.98.
Do we have to do the decimal?
Multiple choice. You should be able to do both. You're all smart kids, right? Number 10. 2 more to go. 2 more to go. Number 10. And if you can cut out all the extra talk, we can get this done really quick. We want a third order polynomial to approximate. Find a Taylor polynomial of order 3 and use it to approximate f of 0.4. E of 0.4. E of 0.4, of course, that's the same thing as e to the 2/5 power. E of x is equal to 1 plus x plus 1/2 x squared. I think we want order 3, right?
Yeah.
1 over 3 factorial x cubed. And that's the third order polynomial right there. Okay, so e to the 0.4 is going to be approximated by 1 plus 2/5 plus half of 4, no, don't do it, 2 over 25 squared plus
Wait, why is it 2?
1/6 of 8 over 125.
Why is it 2 over 25?
4 over
Oh,
25.
you already did.
Should I not simplify that? Yep, there we go. E to the 0.4 can be approximated by 1 plus 2/5 plus 2 over 25
It's 4 over
4 over 2.
No, but then one of the two's cancelled, so yeah.
plus 8 over 1, ooh, gosh,
So it's 125.
4 over 2, no,
8 over
4,
It's 8 over 125, which
hold, 3 times 125 is 375.
Yeah.
oh wait. 7. I got you.
4 over 375.
Oh, I get it.
Gosh, 375.
15.
25 times 3 is 75. 75 times 2 is 150.
Oh, I feel like they're not going to be that.
5. 15 times 2 is 30.
That was an easy one. Oh, goodness. So 34 plus.
3, 4, 475, 525, 555, 554.
Sure. I don't think you're right.
I got 559.
59? Oh, 59. 459.
559.
559.
559.
You need a calculator.
I used the calculator.
No, it's not. 3, 400, 475, 475, 525, 555, 559.
Yeah.
Yeah.
I don't think you can.
Thank you. It's like 2.0.
They left it as a fraction.
I think it likes the way it is.
I don't wanna find that decimal.
Oops. Last one, 11.
Why'd you say oops?
I put my pen down prematurely.
Oh, goodness. Sounds like you killed it. Oops.
I'm not killing my pen. It's not even really a pen.
Can you put your pen down?
Cosine of 2x.
Where is your evil mind at, girl? I'm tired.
Okay. Maybe I should start with cosine of
I
x.
would say the same. Thank you.
In sigma notation.
Cosine of x equals
Equals x
1 minus
minus 1 over 2 factorial x
plus 1 over 4 factorial
4 factorial x.
Yeah. Yeah, no, I think at this point 3 terms is probably okay since we're just trying to figure out the sigma notation. I think we need to put negative 2x in this. So we'll get cosine.
But it doesn't have to. Oh, it's negative 2. Okay, right there.
Oh, I did. You're right. Negative 1 to the n.
I'm getting more pizza. You always have to write that? Oh, I know.
Negative 2x, right? Oh man, look at that. Everything is an even power, isn't it?
Yeah.
So that negative
Oh, it doesn't mean anything.
doesn't mean anything, yeah.
It's 4x squared.
That's it. Oh, special note, because I've gotten this before. Special note. Note. This special note's going to be in red. Note. Sigma. Negative 1 to the n. 1 over 2n factorial. 2x to the 2n is wrong.
Oh, that's parentheses around what?
The 2n.
The 2n.
Oh, that's not how I write it.
Oh.
Okay.
This 2n, 1 over 2n is times
1 over this.
That is wrong. Okay. That kind of wraps it up, I think, right? With that number 11?
So all we have left is number 15.
In class tomorrow.